Assalamu alaikum. Today we are presenting our machine learning project titled English Premier League Match Outcome Prediction. This project focuses on predicting the outcome of EPL matches using different machine learning classifiers. The possible outcomes we aim to predict are a home win, draw, or away win. This project was completed as a part of our classwork under the supervision of Dr. Jamil Ahmed at the University of Management and Technology. I'll begin by explaining the motivation, problem statement, dataset, and pre-processing steps. So let's move on to motivation. Football match prediction is a challenging and widely studied problem in sports analytics. Outcomes depend on many uncertain factors, which makes accurate prediction difficult. Despite this, prediction models are heavily used by bookmakers and betting companies and even by team managers to support strategic decision making. Traditional statistics often fail to capture complex patterns, so machine learning provides a better way to analyze historical data and uncover hidden trends. The main goal of our project is to predict English Premier League match outcomes, specifically whether the match results in a home win, draw, or away win. Let's move on to our problem statement. This problem is formatted as a classification task. The input to our model consists of team performance metrics derived from previous matches, while the output is the match result: home win, draw, or away win. One of the main challenging is the high level of uncertainty in football, as outcomes are influenced by many factors such as form, tactics, and randomness. To address this, our approach focuses on three aspects. First, we perform feature engineering based on recent team form. Second, we train and compare multiple machine learning classifiers. And third, we use a time-based train test split to avoid data leakage and ensure realistic evaluation. Okay, let's move on to dataset description. Our dataset consists of historical English Premier League match data spanning from 2000 to 2022, covering a total of 22 seasons. In total, the dataset includes approximately 7,600 matches with 20 teams per season and 106 original features. Looking at match outcomes, we observe that home wins occur most frequently, making up around 45.8% of matches, while draws and away wins occur much less often. The average number of goals per match is the dataset is approximately 2.7 goals, which is consistent with typical EPL statistics. This distribution already hints at a class imbalance problem, which we address later in the project. Let's move on to feature engineering. To capture team performance effectively, we engineered 18 features on each team's form over their last 5 matches. For the home team, features include recent points, average goals scored and conceded, goal difference, and win rate. The away team has the same set of features calculated independently. In addition to that, we created derivative features such as the difference in points, goal difference, and win rate between two teams. Finally, all features were standardized to have zero mean and unit variance, which helps ensure fair training process different machine learning models. Let's move on to data processing. Before training our models, several pre-processing steps were applied. First, we removed matches where teams did not have sufficient historical data, specifically the first 5 matches of each season. Next, outcomes were labeled and coded, where home win, draw, and away win were mapped to numerical values. We then applied feature scaling using standard scaler to normalize the input features. Finally, we performed an 80-20 train test split based on chronological order, resulting in approximately 59 80-20 matches and 14 96 testing matches with 18 features per match. This ensured our evaluation closely reflects real-world prediction scenarios.
This is Taha. Now I will explain machine learning models that we have used in this. For our prediction task, we evaluated 5 different machine learning classifiers to understand which type of model performs best for EPL match outcome prediction. The first model that we used is K nearest neighbors. which is an instance-based learning algorithm. It predicts match outcomes by identifying the 5 most similar past matches and assigning the majority class among them. Next, we used logistic regression, which is a linear probabilistic model. It performs multinomial classification, meaning it directly estimates the probabilities of home win, draw, and away win. The third model is Gaussian naive Bayes, which is a probabilistic classifier that assumes feature independence. Despite its simplicity, it often performs well on structured datasets like ours. We also tested SVM with an RBF kernel, which is capable of modeling non-linear decision boundaries. Finally, we implemented a neural network, especially a multi-layer perceptron with 2 hidden layers of 150 neurons using ReLU activation and the Adam optimizer. All models were trained on the same standardized features to ensure a fair comparison. Now I will move toward the experimental setup. Our experimental setup was designed to closely reflect real-world prediction scenarios. We used a time-based train-test split, meaning the training data always comes before the testing data. This prevents the data leakage and ensures that models are not trained on the future information. No shuffling was applied, and all models were trained using the same standardized feature set. For evaluation, our primary metric was classification accuracy, while the secondary metrics included precision, recall, and F1 score for each class. We also measured training time and prediction time to assess computational efficiency. For validation, we applied 5-fold stratified cross-validation on the best performing model and analyzed confusion matrices to better understand prediction errors. Now let's move to the model performance. This slide summarizes the performance of all 5 models. Among the tested classifiers, naive Bayes achieved the highest accuracy of 45.3%, while also having the fastest training and prediction time. Logistic regression performed moderately, while more complex models such as SVM and neural networks showed lower accuracy and significantly higher computational cost. KNN had the lowest accuracy among all models. Based on these results, naive Bayes was selected as the best performing model overall. However, we also observed that all models struggled to correctly predict draws and away wins, which is largely due to class imbalance in the dataset. Now, I will provide you detailed performance. Naive Bayes. This slide provides a deeper look into the performance of naive Bayes model. The model shows very strong recall for home wins, correctly identifying nearly 90% of home win matches. However, it fails to predict draws and away wins, resulting in zero precision and recall for those classes. This indicates that the model is heavily biased toward predicting home wins, which is not surprising given the imbalance in the dataset. While the overall accuracy is reasonable, this breakdown highlights the importance of evaluating models beyond accuracy alone. Now we will move towards the cross-validation results. To further evaluate robustness, we performed 5-fold stratified cross-validation on the naive Bayes model. The fold accuracies varied significantly, indicating high variance over cross time periods. Indicating the high variance across different time periods. This suggests that the model performance depends heavily on the specific season or time frame being analyzed. The result reinforced the idea that football match prediction is inherently difficult and affected by both class imbalance and temporal variation. Now, we will move towards the slide discussion. Why this is difficult? Why is this task difficult? This slide explains why APL match prediction is a challenging task. First, the dataset suffers from severe class imbalance with home wins dominating the training data. Secondly, football matches are inherently unpredictable. Many important factors such as injuries, weather conditions, referee decisions, and tactical changes are not captured in the datasets. Third, Our features are limited to recent form over the last 5 matches without including head to head records or player level statistics. Interestingly, we found that simpler probabilistic models like the naive Bayes outperformed more complex models, suggesting that added complexity does not necessarily improve performance for the task.
Myself, Javeria, and I will discuss the key insights, what matters the most. The slides highlights the most important insights derived from our model. Using logistic regression coefficients, we identified the most influential features for predicting home wins. These includes the home team's recent points, goal difference over the last 5 matches, and the point difference between teams. One surprising finding is that win rate was less important than raw points, and goal difference mattered more than total goals scored. Overall, the result confirms the recent form and momentum play a major role in EPL match outcomes, which aligns well with established football analytics knowledge. Moving on to limitations. Although our model produces reasonable results, there are several important limitations to consider. First, the dataset is imbalanced, with home wins occurring much more frequently than draws and away wins. This causes the model to become biased towards predicting home wins. Second, our features are limited to recent form over the last 5 matches. We did not include important factors such as players' injuries, transfers, weather conditions, referee decisions, or team tactics. Third, football is naturally unpredictable, and many match outcomes depend on events that cannot be captured by historical statistics alone. Because of these reasons, the prediction should be viewed as a decision support, not as guaranteed outcomes. Moving on to future work, there are several ways this project can be improved in future. First, we can handle class imbalance using techniques such as SMOT or class weighted training, which may improve the prediction of draws and away wins. Second, we can add richer features such as head to head history, player level statistics, injuries, team lineups, and possession data. Thirdly, advanced models like XGBoost, random forest, and deep learning architectures could be explored. Finally, the system could be deployed as a web application where users can input teams and receive real-time match predictions. Moving on to conclusion. To conclude, we developed a machine learning system to predict English Premier League match outcomes. We collected historical match data, performed feature engineering and pre-processing, and evaluated multiple classifiers. Among all models, naive Bayes achieved the best performance in terms of accuracy and efficiency, although it showed bias toward home wins. Our result confirmed that recent team form and goal difference are key indicators of match outcomes. Overall, this project demonstrates how machine learning can support analytics and decision making in football. Thank you. That brings us to the end of our presentation.